Okay, on this video, we're going to do some absolute value equations. So you start out getting the absolute value alone. So in this case, it's being divided by 8, so I need to multiply by 8. So I'm going to move this 8 by multiplying. So I'm going to have the absolute value of a plus 1 is equal to 24. At this point, I take this absolute value and I remove it by breaking it into two equations. And I have my students in my classroom make little arrows like this. I think it really helps. So the first equation is just when you get rid of the absolute value bar. So it's just a plus 1 equals 24. The other one, you change the sign of this. So you have a plus 1 is equal to negative 24. So that's because 24 has an absolute value of 24, and also negative 24 has an absolute value of 24. So this inside, which is a plus 1, could be 24 or negative 24. So that's why we have these two different equations. Now that the absolute value bar is gone, you can work the equation. So you subtract 1 from both sides. So here you get a equals 23. And here when you subtract 1 from both sides, you get a equals negative 25. So that means a positive 23 or a negative 25 could be plugged into the original equation for a, and you would get 3 either way, okay? So something you have to be careful about is that an absolute value, because it's always positive, can never equal a negative number. So when you're looking at this equation, you've got this absolute value and it equals negative 8. So at first glance, you might be tempted to think, well, that's no solution. That can't happen. But you cannot make that decision until you get your absolute value completely alone. So you have absolute value minus 10. So you need to add 10 to both sides. Whoops, add 10 to get it alone first. So you have absolute value of negative 3 plus b. And now negative 8 plus 10 is equal to 2. You have a positive number. So you don't have a situation where it's no solution. It kind of looked like it at first, but you have to get your absolute value alone, then you can judge. So now that we have our absolute value alone, we can break it into two equations. So we have negative 3 plus b is equal to 2, and negative 3 plus b is equal to negative 2. So, oh, sorry, I'm zoomed in too much. So you have your regular equation, what I call the regular equation, where you just get rid of the absolute value bars. And then you have the other one where you change the sign of the answer. Do not ever change the sign on the inside. Technically, you could say a positive 3 minus b is equal to a positive 2. You could leave the outside the same and change the sign of the inside, but that is more complicated. You'll be much better off if you leave the inside alone and just change the sign of the answer, the number by itself. So now you're just ready to add 3 to both sides to solve this. So b is equal to 5. And then when you add 3 to both sides here, you get b is equal to positive 1. Okay, so I can have more things on the outside of the absolute value to make it a little bit more complicated. Do not fall into the trap here of adding the 10 and the 5 together and getting 15. This 5 is being multiplied by this absolute value and the 10 is not, so you cannot put them together. So your first step here is to subtract 10 from both sides. We're going to divide in a minute. But I want to get rid of that 10, so I'm going to subtract 10 from both sides. So I have 5 times 8a minus 1, and then 45 minus 10 is 35. Now I need to get my you're always trying to get your absolute value bar alone. Really, in any equation, you are trying to get the complicated thing alone. Just remember that. No matter how hard a math class you're taking, how far you go in math, when you are solving an equation, you want to get the most complicated thing alone. So in this case, it's the absolute value. So we're going to divide both sides by 5. Do not subtract 5. This is 5 times that, not 5 plus that. So we need to divide. It's a very common mistake, and it gives me the heebie-jeebies. Okay, so 35 divided by 5 is 7. Now I have my absolute value bar alone. I can break it into two equations. So I have 8a minus 1 is equal to 7, and I have 8a minus 1 is equal to negative 7. and I've run out of room on my paper, so I can get some more paper here. Okay, so this one is pretty straightforward. When you add 1 to both sides there, you're going to get 8a is equal to 8. That's easy. Divide both sides by 8, and you get a is equal to 1. No problem. But over here, I'm just going to recopy this. So it's 8a minus 1 is equal to a negative 7. Okay? So you're going to add 1 to both sides. The problem is you get a negative 6, and when you go to divide by 8, that is not an integer. And a lot of students will think, well, I've done something wrong. Nope, you're just going to have a fraction as your answer. So reduce that to lowest terms, and a is equal to negative 3/4. So you may get fractions on some of these. You could take 6 divided by 8 and get 0.75 and tell me the answer is negative 0.75. But I want you to get comfortable with fractions instead, because if this would have been 2/3 or 7/9, then the decimal equivalent isn't actually equivalent. It's just an estimate because it's a repeated decimal. So you would have to round. So it's just easier and better to work with fractions. It's better. It might not be easier for you yet, but when you get good at fractions, they're easier than decimals. Okay, so that's those 3. Let's talk about a couple different situations with absolute value, okay? So let's say you have a problem like this. So you start out by adding 7 to both sides. So you have the absolute value of negative 6n, and then negative 67 plus 7 is a negative 60. So in this case, you do have no solution. You have an absolute value that is equal to a negative number. And you could go ahead and make 2 little arrows and work the problem, and you wouldn't get anything weird. You wouldn't notice that you've done something wrong because it'll work out okay. It's just if you took those answers and plugged them back in, they wouldn't work. You would get 60 as an answer instead of negative 60. So once you get to this point, if you have an absolute value equal to a negative number, you stop. You don't have to do any more work, and you say no solution because you cannot make an absolute value equal a negative number. Okay? Over here, if you add 1 to both sides, you get that. You get your absolute value alone, okay? And I just want to show you this one. It's really not hard. It works out a little bit different. So you change it into 2 equations. So you have x over 6 is equal to 1, and x over 6 is equal to negative 1. So when you go to get your x alone and multiply by 6, you get x equals 6. And here you get x equals negative 6. That doesn't happen very often, but sometimes you get the exact opposite answer. You get 6 and negative 6. So that actually happens when you have a multiply or divide on the inside of the absolute value and you don't have a plus or minus. So that will happen, but don't think that that always happens. Please don't get a number here and then assume that your other answer is the opposite of it. Sometimes it works that way, sometimes it doesn't. Okay? So that finishes up those examples on that section.